so we know that the area of the smaller circle is 4/9 of the larger circle. We're told the radius of the smaller circle is 6.2 centimetres. So I know the area of the small one would just be pi r squared, and that comes out at being this number here. So that's 4/9 of the larger circle is equal to that. So if I know 4/9, I can find 1/9 by dividing by 4. Okay, does that make sense?
Yeah.
So then I've divided both sides by 4 to get 1/9 of the circle is equal to 30.1 blah blah blah. And then to find 9/9 or 1/2, so to find what the area of the larger circle is, I times by 9. But I didn't think that was obvious. I thought it was a good one to look at with me. So the shaded would be the area of the large circle, take away the area of the small circle, which would be 150.95 centimetres squared to 2 decimal places. But then I reread the question, it said to 3 sig figs. So I need to go and change that to 151.
Sig figs.
You must have heard no. Oh, it's a new one.
It's like old seg, isn't it?
Yeah.
No, it's not.
This one here, I don't know why I printed off in hindsight, you know, it's very easy. 5 marks. If that comes up, then happy days.
Yeah.
Oh, that looks fun.
This one here, reflect the shape in the x-axis, just make sure you're reading what to do. This one here rotates 90 degrees anti-clockwise. What haven't I done there?
1 to the -1.
There we go. I didn't put my crosshair on there, now I have. So when you trace it, it makes it really nice and easy for you. This one here, I alluded to this one earlier. It said go and find the centre of enlargement and find out what the scale factor is. So this was my original shape. You just join up where its corresponding thing is. So that one to there, that one to there. And where they cross over, that's the centre of enlargement. So that will always happen. Okay? So the centre of enlargement was 0, 0. It's the origin. And the enlargement, because it went backwards on itself, we're told, it said the scale factor of the larger triangle to the smaller triangle. So I was there and I went here, so I actually went the opposite way. So that told me it was minus, and it went half as big. Okay?
Yeah.
I'd not expecting that to come up. I don't think negatives would come up. In standard form, pretty bog standard, pretty straightforward. I'll just show the answers there. Quadratic formula, make sure you're nailing that, easy if it comes up. This one here, I didn't like what I did to begin with, right? So originally, I checked the mark scheme. It said a tile is made so the sum of its length. Oh, I've just realised I've messed this up. Right, this is a stupid thing. It says the sum of its length and width must be 20. Okay, I've done the products. Yeah, I've times them together. So mine really is stupid. Okay, your one would just be a straight line. So I was looking, I was thinking, well, is it true that it would be a curve like that? So I didn't know if that was actually true, and it probably isn't. If you do it with the sum, it's literally just going to be a straight line going through these points here. Hi, Miss. No, Miss. Mr. Anderson's been in, and he has recorded a maths lesson. Yeah, that's what it should be. It should be that pencil line there. Okay, so then if you read off the 5 add 15 is 20. Okay. You don't fancy it, do you, Miss?
No, absolutely not.
I was very impressed that you did it, Miss. I honestly, hats off to him to come in. Have a go. A hard question as well.
It's typical. It's quite sort of brave in that way.
Yeah, fair play.
Over the top.
You sure you'll have a go at similar shapes, Miss? I mean, I know it looks really exciting.
I would definitely embarrass myself discussing maths, so I'm not even going to try. Enjoy.
That's okay.
Look at this one here. Scale factor. Am I doing area there?
No.
Why not?
It's a line.
Good. It's a line. Even though we put it in the middle, you think it's area. It's not. It doesn't say centimetres squared. Okay. So to work out scale factor, small times scale factor equals the big one. Rearrange it. Scale factor is 1.6, and then the small one to the little one I divide to get 5.2. Then it tells me what the area of the smaller one is, so I times it by 1.6 squared, and it's that. Okay. And this one here, I quite like this one in terms of the start, because I felt a little bit different. So how do you work out the area of a triangle?
Half A,
Half base times height, half A times B, or whatever you want to say. And I know that that is the area. They told me that. So I got rid of the half by timesing both sides by 2, or bringing this over as a divide by half, which is like timesing by 2. Then expanded, then rearranged in their form, and it does work out to be in that. Okay. This one here, something like we were very, very good at doing these in class at the time. Maddie, Emma, thank you. You've got to find DEC, so that's this one here. So at the moment you have 2 pieces of information. We need a third. So we need to go and find either this angle here or this side here, and either of which don't look that obvious. But if you come to this one here, you've got 2 sides and angle. find this side, then you've got one side, two angles, so you can then find this side. So the idea was to use cosine to begin with, then you put that into the sine rule, and then you should find out that that is, oh yeah, it's area, isn't it? Sorry, you need to find this one here, the area. Thank you for pointing that out, Luke. So you need to find this side here, because those two sides meet at an angle. Thank you. Okay, all good? So it equals 10.9. This one here I've not done because my gut feeling was, it's question one of a paper. It's QWC, it should hopefully be quite straightforward. Again, bearings I've not done, so I think you're pretty good, but I'm expecting to see bearings tomorrow. This one here I felt was quite interesting. Thank you. 800 students from the UK, 300 students from Russia applied to attend a summer camp. 20% of the UK students are selected and 30% of the Russian students are selected. What percentage of students who are chosen attend the camp from Russia? So I know that 20% of the UK applicants, that's 160 UK applicants get on. I know 90 Russian applicants get on. So that's 20 and 30%, so a total of 50%. So a total of 50% is equal to 250, so the entire camp must be made up of 500 people. Yeah? And then percentage from Russia would be the 90 out of 500 times by 100. I didn't think that was obvious, that one. I looked at that and I didn't look and go, oh, it's obvious, this one. It required a bit of thought. I didn't do this one. I sort of wanted to do this one in some respects with you. Would you do you feel confident with that? Does anyone actually want me to go through that very quickly? Yeah? Okay, so 72 games are played. So if I want to work out how many people got no points, 60 degrees out of 360 times by 72 will tell me exactly how many people got no points. Okay? So I think that's a sixth, so that would be a sixth of 72, which is 12. Okay? But you've got a calculator, just stick it into that if you want. 30 degrees, so that would be 30 out of 360 times by 72, and so on. Okay? So that one there would be even less, then that would be 6. Okay? So you can work out the rest from there. I then asked you to work out the mean as well, so there's a fair bit going on with that. That wasn't an obvious question. We've done that bit. This is the one I was talking about, yeah. Now, the way that I do this, I don't like the fact that you've got 3 things in one go. It says, on the first day, it took 10 hours for 3 of these trucks to move 100 tons of soil. On the second day, it took 5 trucks, or how long did it take 5 trucks to move 150 tons of soil? So the first thing I do is I work out in the first scenario. I remove it from being 3 trucks to 1 truck. So if that's dividing it by 3, if I've got a third less help, then that's going to take the time 3 times as long. Does that make sense? It's basically inverse proportion. So that's still for 100 tons of soil. So then, to get 150 tons of soil, that's half as much again, isn't it? So it would take half as many hours. Does that make sense? So it's going to be 45 hours because half of that is 15 and add it on to get 1.5 times as much because that's what I do with the soil. Yeah, half of it being 50, add it on. So then I'm looking at 45 and we're told that it takes, for 1 truck, I've got 5 trucks. So I'm actually going to get it done 5 times quicker. So what am I going to do to the hours? Divide it by 5. Okay, so that got times by 5. So this one divides by 5. Okay? But not obvious, and David found one of those, and he took me up on it, didn't you? I messed up about 3 times before I actually had the right answer, because I kept on, I wasn't reading the question, and luckily for me, Maddie had the right answer, so I could check with the answer. So I don't know where you found it from either. It's like, I actually got this question. It was in one of the number packs.
Yeah, the ones he gives.
This is what I am expecting to see this tomorrow. Okay, I've alluded to this a number of times today. It says this was an improvement of 8% on its previous best. So it's not even saying, it included the VAT or anything like that. It wasn't obvious that was 108%. Okay? Do you see now that you know that it's that? Do you want me to try and pick out the literature? I don't know how I really noticed it. I just know it's there. You think, though he threw the javelin, he threw it that much, which was an improvement of 8% on his previous best. So his previous best would have been 100% of what he was capable of. And he increased that by 8% because it was an improvement. So it was 100%, add the 8%. And because that's what we were given, that's how I was able to put that into that. So I divided both sides by 108. That gave me 1%, times it by 100 to find 100%. Okay? Pretty nice marks when they come up if you know what you're doing. This one wasn't easy. The thing that I didn't like, this messed me up in my solution. You'll see like some scribblings on my work. Go on, Paul.
I don't understand the percentage one.
Yeah.
Yeah. Yeah. Good point.
No,
You were paying attention to that. Okay, so in a competition, Dewi threw the javelin 69.93 metres. This was an improvement of 8% on his previous best throw. So on his previous attempt, they said, "Oh, what can you give when you're giving absolutely everything?" 100%. That's all you physically can give. That was what he did originally, but this time he was 8% better than that. So 108% is equal to that. So basically, I've just divided both sides by 108.
I see.
Okay?
Yeah, I didn't understand how you got through.
That's all right. I'm glad you asked. It's important that you ask if you're unsure. The thing that I didn't like about this one then, look, it goes 70, 50, 30. Then here, the first thing it tells you about is 50 miles per hour. So just be careful when you're looking up the data from here. Okay, now the fact that this is telling me miles per gallon and then it's giving me a speed is absolutely no use to me. I need to turn that into speed, distance and time triangle and actually work out how many miles were travelled. So constantly driving 50 miles per hour for an hour and a half. So if I do 50 times 1.5, be careful of that, 1.5 hours, not 1.30, 1.5, that would be 75 miles that's travelled. So then, reading from the table, when I'm driving at 50 miles an hour, I get 48 miles to the gallon. So I want to do 75 miles that travelled in that time, divided by 48. And that was a horrid number, so I just left it as a fraction. For the next one, for 70 miles an hour for 3 hours, that's a total distance of 210 miles travelled. And then your miles to the gallon, if you read up in the table a little bit higher, that's 42 miles to the gallon. So you divide that by 42 and that comes out as being 5 gallons used. And then for the last bit, 30 miles per hour for 30 minutes. So that's going to be 30 times 0.5, which is 15 miles. And then I divided that by 40. That gave me 3/8 of a gallon. So then I just added them all up together, which gave me 6.9375, which is 7 gallons, the nearest gallon.
I don't get how gallons and miles work.
So your car will basically do it for you. If you get like anything made after about sort of 2008 time, they'll have like computers built in, so they'll monitor how much petrol you're using. And the standard that people tend to use is miles to the gallon, which is silly because we buy petrol by the litre. So you've got to know that 4.5 litres is equal to 1 gallon. In terms of that one there, it's saying miles per gallon. That's telling you to do miles per means divide, like percent means out of 100, isn't it? Divided by 100. This is telling you to divide by the gallons, okay?
But isn't it always the same?
Yeah. Well, no, it depends how you drive. The faster you drive, the worse your miles gallon be. But here, I don't particularly agree with that unless it's in traffic. If I came to school, which I do, I average about 30 miles an hour, probably a bit less actually, maybe 25, because there's traffic lights and stuff, and it really affects my fuel economy. So I filled up a full tank, and I'll probably get about 300 miles out of it. If I just drove on the motorway the whole time, because you use all this energy to get up to 70 miles an hour, but then you're just already at 70, you're just maintaining that. You're not actually having to burn more fuel to do that, you're just maintaining speed. So you actually get really, really good petrol consumption. But if you're driving like 80, 90, it's not what we call a linear relationship. So it won't be like, if I'm going twice as fast, I use twice as much energy. It does like a quadratic like that. So if you're going like twice as fast, you're probably using about 8 times as much fuel to get that energy. So it's more economical to drive at slower speeds. So I don't quite know why they said 30. I'd expect that to have been larger than the 50, to be honest. But if you stop at traffic lights, your engine is running, then that obviously costs a lot of fuel.
Catch it.
Why don't sort of fix up automatically?
Yeah, you can get those. Although it does cost a fair bit of money to start your engine every time.
She was really confused just when she drove it.
Right then, this one was really fussy. You didn't know what the angle was, but you did know what the shaded area was. So I've written it out as the shaded area would obviously be the whole big thing here, take away the small one. So that is going to be that angle divided by 360 times by pi r squared for the big section, so times pi times 10 squared, and then minus x over 360 for pi times 6 squared. Are you happy with the first bit?
Yeah.
Hard idea to get your head around this bit. What do you notice about both of these bits? What's in both?
Fine.
The x bit. Okay. Now pi is in both, But I want to get x on its own. So if I brought pi out as well, it'd just be one more factor. It's not really going to help me. So then in the line below, I pulled that out as a factor. And in here, I've got pi times 100 minus pi times 36. Then I took this across to divide by. And at the same time, I took this divide by 360 around as a times by. So that became 360 times by the top number. And then this became a divide. And I just put the 100 being 100 pi and 36 pi. And it works out at being 86 degrees.
That's really complicated.
Yes, it is. That's a bit of a stinker. And it wouldn't surprise me if that came up because I am expecting a bit of a nastier paper tomorrow. So just be aware. Not a bad idea to look at this one again tonight and just try and follow through what I did because it is a nasty question. Okay, it's going to be the sort of thing that I'd be very annoyed if something like that came up when we know how to do it normally and they're just trying to make you think. So you've just got to try and show as much work as you possibly can here. Okay? Josh, you alright there?
Yeah.
Are you sure? Do you want to move behind and live behind that? No. Stop shaking it then, please. This one here. Okay, make sure you listen, please. This one here I haven't actually done. It won't take long to do at all. The radius of each hemisphere, which is also the radius of the cylinder, is 15 centimetres. Okay? So basically, it's asked me to calculate the volume of this wood. So this solid wooden object is formed by removing two hemispheres. So they just cut in here and cut out there. So basically, I want to work out the volume of the cylinder, which would be pi times r squared, so that would be 15 squared, times by how long this thing is. Now, we know that a hemisphere, that would be a radius there as well, wouldn't it? This would also be a radius. So how long is the entire thing? 30. Very good. Okay, times by 30. That would equal whatever it equals. And this you just use from the formula booklet. I think it's 4/3 pi r cubed. So times by 15 cubed. That equals whatever it is. And it's that. Take away that. And Bob's your uncle. Done. Okay. Oh, I missed one from the previous part about that circle bit. It said calculate the length of the arc, so I just did that angle divided by 360 times pi d. Okay? This one very similar to what we just looked at, except this time it's a cone, and they wanted it done algebraically. You were told that the sides of the cube were x, so this is x, x, and x there. Here, you were told that the radius of that was 0.4x, and the height was 0.9x. So it says calculate the volume once the cone has been removed, or you're told that it was equal to 849.2. So the first thing I did was I said x cubed, that would be the volume of the cube, just x times x times x. And then I've subbed in those measurements into the cone formula, although I didn't do a great job. I ran out of room. Do you see what I did here? That bracket shouldn't be there. Okay, that should be times by 0.9x, like that. Okay? So that comes out. So basically, the thing that you're more than likely to make a mistake here, what's 0.4x squared? What does it mean?
0.4x times 0.4.
Good, 0.4x times 0.4x. So that 0.4 times 0.4 is going to be 0.16, but you can stick that into your calculator if you're unsure. Then you're going to have the x squared. I've got a third times in by that. So basically what you need to stick into your calculator is just the numbers. So 1 over 3 times by 0.4 squared times by 0.9. You know, I wouldn't be doing this in my head. And then that comes out, that's wrong, so I plussed it. There we go. It comes out being 0.048. Okay, so just stick the numbers into the calculator if needs be, because it's not nice to work this out. It's near the back as well. You expect this to be a pretty rank question. You still got the pi, so that pi is still there. We can't see what we're doing here, can we? We still got the pi, so that pi's there. And I put it equal to what they told me in the question. But why has that become x cubed? It was x squared here times by an x there, so that's why it's x cubed. Well spotted. Then, very similar to like I just did with that circles question, x cubed is in both, so I pulled it out as a factor. Then I had 1, because x cubed times 1 would be x cubed, yeah? And then I had minus 0.048 pi. Okay? That's then equal still to that, that volume they told me. I then took over the bracket to divide by. That gave me an answer ludicrously close to 1,000. And I was thinking, when I had that answer, I thought, well, that's good because 1,000 is a cube number. It's 10 cubed. And when I cube rooted that, I got 9.999. And I'm looking at those numbers and thinking, well, I obviously nailed it. Okay, so it's a good indication if you're getting that close to a whole number, you should be feeling pretty confident. Maddie?
Why are you finding x cubed?
I'm not. I'm finding x overall, but x cubed was in it to begin with, wasn't it? Because I was told the volume of this thing. It says the volume of that, so the volume of that is the cube. So the volume of this is x times x times x, isn't it? Which is x cubed.
Oh, I was reading the code.
That's right. Okay.
What?
Almost done. Good effort. We've finished strong here.
I'm so my brain's been tossed.
Okay, and I'm going to skip a few of these again. I only picked this one just because I thought, yeah, nothing like that came up in the first. Did we have speed distance time go up on the first paper? I don't think so, so I just stuck it in. That is a Welsh one. You did you? Yeah, speed distance time. Trial and improvement, I'm not going to go through that. Hopefully you're really good at that. We were rubbish in our mock and we've nailed that to death now. So I'm happy with that. This one here, again, pretty pedestrian. I wouldn't have thought we'd struggle with things like this.
Yeah.
Bit of problem solving. I didn't get my QWC marks because I didn't explain what I was doing. That needs to look more obviously like a 5. The thing you've got to be careful with here, even though it's 4.15, you go, oh, round it down, it's not, but you need 4 and a bit tins of paint, okay? So you need 5 tins of paint then in that case to paint this room, okay? We have frequency polygon. You know I wrote these answers because... Why? Why is it obvious I did it? What do I do? I blocked out the midpoint, do that so you don't accidentally add them up. It actually asked you to go and estimate the mean after that graph. I thought that's quite a nice way of actually mixing the two things together. It's giving you extra marks for it, and I wouldn't be surprised if they try and do some sort of tweak like that with something tomorrow. So I just read off where these were, so you had to just read the scale for that, okay? So you end up going and finding the 32, the 30, and so on by here. Okay, midpoint's pretty obvious. What's the midpoint is 0 and 20, 10. And then midpoint times frequency ends up working out being 35.2. And then you had some data on the other side here, and they asked you to go and plot that on the same graph paper. So I went and plotted that, and then it says, can you make some comparison about these two shops? Basically this one here, the one I plotted, they spent more money. I can see that because it peaks at a higher place. Okay? That's literally all I said there. So people spent more money in the frequency polygon I drew. Then some bearings, which I've not bothered putting in, or maybe loci. Yeah. Well, not if it's loci. Standard form. Again, when it comes up in your calculator. Okay, thanks guys. Have your attention please. I know it's been a long day, we're really close to the end, but I've really only got like a couple of pieces of paper to show you. Still waiting. That wouldn't be, certainly not to the power of 3, it'd be 6 times 100, wouldn't it?
Oh, yeah,
100 is 10 squared. There'll be, if standard form comes up tomorrow, which we are expecting it to come up tomorrow, it will be that it gives you an answer that's not in standard form that you have to put in yourself. Okay? Yeah.
Can you do the notes?
Yeah, maybe I can do that in a second. Yeah. Is it definitely localized? I've not read it yet. Okay. I wouldn't be surprised if this comes in. This is due an appearance. It's not been in for a while. You need to know the formula for this, but you can more or less deduce it from looking at the volume of a cone, because the volume of the cone is a third pi r squared h. Pi r squared is the base area, so you just need to know that formula, that the volume is base area times height, and I should have said a third. I haven't done that. So I need to divide this answer by 3. So 225 divided by 3 is 75 centimetres cubed. Oh, there you go, just when I spotted that, isn't it? Okay, all good? And then cumulative frequency again, should be pretty easy marks. Just the last one, similar triangles. I didn't like this one at all because it didn't tell you anywhere that it's actually 90 degrees here. You just had to assume it, and it doesn't look like 90. I know it says not drawn to scale, but it doesn't look like 90 at all. You're told that AB is 10, BC is 2, and the area of ABE, so this one here, is equal to 24 centimetres squared. So the only way to sort of go anywhere at all with this was to do half base times height is equal to 24 and just assume it was 90 degrees. That's all I had. That's all I did. And that worked out being 4.8, so that was this base here. Now, this is similar triangles, but it's just not obvious to see. I've drawn them by the sides, like split into two separate ones. So this is 10, and I've just found that's 4.8. And then this one, which encompasses 2, is now 12, isn't it? So how would I go and find what its base was there? I'd find out what the scale factor is, 12 to 10. So scale factor is going to be 12 divided by 10, which is 1.2. So then you times that by 1.2, I think it's 5.76, yeah. Okay? So then, to work out the area of the trapezium, so that's the parallel sides, half the parallel sides times by the height. So half A plus B times by H. Because I had a half and times by 2, they just cancel each other out. Okay, if I had a third times by 3, cancel each other out. So then it's literally just those two added together, which is 10.56 centimetres. But I felt that wasn't an obvious one. And again, you're good at similar triangles. Something like that comes up, please don't let it fool you. It is there, you just may have to draw them in yourselves. Okay? And anything on the back? Yeah, this one was a good one to do. And I made a really good mistake as well to show you. So 17, it says that the sides are kite, so we know what a kite looks like. That thing you fly in the sky. That, yeah? Yeah? You know the ones? It tells you two of the angles inside the kite are 130 degrees each. So I drew mine, I split it, and I was about to put in 130 and 130, and then I realised those two there obviously aren't the same, are they? Which two are the same? These ones here are the ones that are obviously the same. They're obviously not the same, whereas these are the same. So I had to redraw it down here and put in 130 and 130 there. And it asks you to calculate the area of the kite. So if you look at it, because that's 6 and that's 11, that's 130, it's just going to be a half AB sine C times by 2 because two triangles. So then again, the half and the times by 2 cancel out, and it was that. Okay? So yeah, I'll have a go at doing that loci one. I think it's going to be loci as well. Okay, I need to go grab a cup of Scotland. I think so, yeah. Okay, guys, 5, 4, 3, 2, and 1. Thank you. So you don't get it, do you? When you're recorded, don't do weird things like that. Right then, it says Leah. Thank you. Leah is drawing a map. Leah is drawing a map of her local area. She has accurately plotted the positions of the villages Kaya, Abba, and Bont on the map below. Leah now wants to plot the position of her house. Her house is the same distance from Abba as it is from Bont. This is definitely loci. Because it's the same distance, I want to do what we call a perpendicular bisector. In terms of what we're going to do, we are going to join up Abba and Bont. We're going to open our compass to just more than half. Not drastically more, just more, but clearly just more. Okay? So probably about there. Okay? So if I draw an arc from Bont, I hate doing this on camera because I usually mess it up, and keeping the compass exactly the same width, don't change it, you then basically get it to cross both of these. There we go. And you then draw a line going through these two bits here. Okay? Now that has created 90 degrees there, but what it's also done, everywhere on this line is an identical distance from Abba and Bont. If I went to measure from Abba and then to Bont, it'll be exactly the same. In fact, I might even draw this line go further along the page. So anywhere on that line is exactly the same distance from both, okay? According to the scale she is using, it needs to be plotted 6 centimetres from Kaya. So what I need to do is open my compass to 6 centimetres. Side, so 6 on there. Okay? And then from Kaya, so basically, I want to draw. A lot easier said than done when you've got a camera just above you. An arc there. Now, so disappointing, isn't it? I'm going to stop there. Rather than drawing it the whole bit around here, any of this stuff's clearly closer to the bombs, isn't it? Clearly close. And all this stuff above the line is clearly closer to ABBA. So it says, find two possible locations. So it's here or here. Okay? All good?
Yeah.
So that's a good one. If that comes up tomorrow, happy days. That's not a bad question at all.